review. There are rigid motions are any transformations that do not change the size and the shape of the object. Any size or shape, or any transformation that does not change size or shape. We went over 4 huge transformations. 3 of them would be considered rigid motions. So that's what I'm going to start class off with today. 3 people, give me those 3 transformations that do not change size or shape, so they would be considered rigid motions. We went over 4 of them, but the 4th one does change the size, so we can't include that in rigid motions. So any of the transformations we discussed, which ones would be considered rigid motions? Start us off right here. Dylan, what do you have? Translation, a slide. Good start. That's when I slide a figure up, down, left, and right. Yep. A translation. What else would not change size or shape that we discussed? Let's go, Simon. Rotation. Good. Turning a figure. Turning a figure does not change the size or shape. And then we had a final one that we did. Does not change anything. Alyssa? Flipping it. Another name. Flip. What's that? Okay. Reflection. Okay. A reflection does not change size or shape. It does change something else, which we'll talk about here today, but it does not change size or shape. All right, those are the big 3 that are considered rigid motions. All right, go to number 2 for me, please. Remember how we do this? I'm not going to do every single problem. You'll finish the ones we leave blank. Number 2, I got math and x, w, y, z congruent to each other. Which one's true? Which one's true? This is a reminder to everybody that these quadrilaterals are written in a specific order. So they match up the sides and the angles for you. I don't have to draw a diagram. It'll match up the sides and the angles for you. So you look at choice number 1, is MA equal to XY? Oh, yeah, sure, they're congruent. You didn't look at the way I wrote it, though. Everyone see where MA is located? Is it in the same spots as XY? No, so they're not equal. MA would be equal to WX. See how they're in the first 2 spots. So that's out. Number 2. We don't need a calculator for this one. Trust me, we don't need one. So let's focus on number 2 and not number 1. Coming strong. H and W. H and W. Are they in the same 2 spots? No. H should be congruent to Z, and W should be congruent to M. So that's not going to cut it. All right, quadrilateral WXYZ can be mapped onto math using a sequence of rigid motions. What do you know about rigid motions? Doesn't change size or shape. What do you know about congruent? Doesn't change size or shape. There it is. Choice 3. Go through choice 4 with me now. I know it's wrong, but let's fix it to make it right. Those 2 are the same shape, but not necessarily the same size. That's not congruent. That's what word instead? Similar. That would be if I change the word congruent to similar. I would choose number 4. All right, we all set? All right, moving on. I'm going to do number 4 now. Number 4. I got a lot going on here. Rectangle, 2 lines, L and M. Which one of these 4 choices brings ABD onto CDB? Before we start testing these out, a reminder. If you're going to put ABD onto triangle CDB, their vertices need to match up. Meaning, as you go through each of these choices, and I'm going to go through 4, I'm going to call on 4 people and go through each choice with those 4 people. Look, A has to go to C. B's got to go to D. And D's got to go to B when you choose your answer. All right, so whatever you pick up here, those 3 points have to match up with the 3 on the other triangle. All right, here we go. I'm going to go one by one here. Whether it's the right answer or not, doesn't matter here. Zoli, you're up. You're going to go through choice 1 with me. So here we go. Point A. Focus on point A. Zoli, everybody else as well. Reflected over line L. Where does it go? Okay, so I'm at point B now. Followed by a 180-degree rotation around point E. So Zoli and I right now are on point B. It's only 180 degrees, meaning opposite side, straight line. Where's B going to go on to? Up. Not it. Should have went to C. Everyone right? Should have went to C. If these two triangles are going to match up, A should have went to C. So that will not cut it. All right, let's keep going. Somebody else for choice 2 now. Jared, ready? Let's start with point A again, Jared. Point A, a reflection over line L would go to where? B. And now it says reflect that over line M. Where's B going to go? Oh, okay. I'm not getting happy yet, but I'm going to keep here, though. I'm not going to cross it out, at least. All right, let's do it again, Jared. Start at point B now. Reflect it over, where am I reflecting? Line L. Where are you going? A. Take A, reflect it over line M. Okay, we could check the next one, but it's going to work. Okay, so that one's going to work, but I still want to go over why the other ones don't work, though. So you guys, because some of you guys, if I left it to you, might have picked one of those choices. Nope. Hopefully people are watching videos here, huh? Jonathan, you're up with me here. Let's go over choice 3. A reflection about point B. So let me go to point B first. That should have went to D. So if you remember, Jonathan, maybe not, that's fine. If I rotate a figure around the point we're rotating around, where's it go? I'm taking point B, but I'm rotating around point B. So it's not going to go anywhere. Good. Point B is going to stay point B, but it should have went to D. Should have went to D. That's why that's not working, because point B is going to stay right where it is, and that's a problem. And the final one. Why doesn't choice 4 work here? Lily, ready? Reflect it over DB now. Where's D going to go? Ooh, I'm reflecting it over DB. Where's D going to go? Where's B going to go? It's not going to move. B should have went to D, and D should have went. They should have flip-flopped. They're not moving if it's on the line of reflection. They're not moving if I rotate around the center. So that's why 4 wouldn't work. Points don't move sometimes. They don't move. All right, good with everybody. All right, let's keep going. Whew, I can suspect this will probably come up here in a couple weeks. Number 5. Before we start anything, I'm going to make this into a 2-part question. Part A is the one I've asked here. All right, so make sure that's part A. Part B, because they probably will ask this, is prove triangle dog is congruent to triangle cat. And we are not doing a statements reasons, HL, side. We're not going to do that. All right, so 2-part question, because I want to make sure we get that special wording right. I don't know if anybody remembers the special wording we needed to prove 2 triangles congruent on the transformation question. All right, first thing you need to do, and I'll give you a couple minutes to do this on your own, is make sure the order matters. Matt, how do I get dog onto cat? Reflection, rotation, translation, combination of the 2. How do I get dog onto cat? That's what I'm asking right now. Let me help you out. There was a little trick I showed you to see if a reflection was involved. Orientation of the vertices. So go to C, A, T, back to C. Is that clockwise or counterclockwise? Think about the clock. Which direction am I going there? To C, to A, to T. Is that a clockwise or counterclockwise direction there? Zoli? C to A to T, back to C. That is counterclockwise. All right. Go the same order for dog. So make sure it all matches up. I went CAT, so now I got to do DOG now. So if we go D to O, O to G, G to D, what direction am I going now? Clockwise or counterclockwise? Where am I going there? Cormac? That's clockwise. So everybody see that it changed? Only one thing makes it change. Reflection. So at least you know going into this answer, you have to at least tell me a reflection is involved. It may be a reflection in something else, or maybe just a reflection by itself. Highly doubtful here, but all right. So go ahead. I'll give you guys a couple minutes to figure out how to get dog onto cat. It's got to be that order. That's what it said in the directions. How do I get dog onto cat? And at least you guys know there is a reflection involved because the orientation changed. If you want to talk about it with other people, go ahead. I'll give you guys a minute or two to let me know how do I get that one onto cat. And it's got to work for all three letters. Just can't work from D to C, and that's it. It's got to work from O to A, G to T. What's up, Stephanie?
I'm confused.
Okay, what's up?
I'm just confused.
Okay, you have to, using translations, reflections, rotations, you need to make DOG land on top of CAT. So do I reflect over the x-axis? Do I reflect over the y? After I do that, do I translate it, slide it? Do I turn it? 270, 180, 90. I'm looking for a combination of those that gets DOG onto CAT. Okay, so D's got to go to C, O's got to go to A, and G's got to go to T. Similar to the multiple choice. I want something like this. All right, what gets that triangle on top of that? And be specific too, because I just don't want the word reflection translation. A reflection over what? A translation, how many right, how many up, how many down, etc. Okay, that's what I'm looking for here. Yep. All right, we got something here. Hopefully we all had the same one, but maybe I'll listen to different ones. I don't even know if there's different ones. Dylan, what are you doing there, big dog? That's what I had. I had a reflection over the y-axis, then a translation up 5. Anybody have any different so I can check it at least, and you can keep it and don't have to erase. All right, so here we go. Triangle dog is reflected over the y-axis. Make sure we write this all out here. Over the y-axis, followed by a translation up 5 units. So there's part A. That's how I can get dog onto cat. Part B, and part B is just going to be a continuation of what we just wrote. Why are they congruent? And this is certain wording that we're looking for, right? Certain wording. I'll start you. Maybe some of you guys can finish. Reflections and translations. I'm just repeating what I did here. Reflections and translations. Anybody want to finish this? Are, there we go. Just like riding a bike. Rigid motions, which preserve two things. What do they preserve? What do we got? I use, you could say side length. I always use the word distance. You can use side length too. That's fine. Preserve distance and, or side length. And what else is it? Angle measure. Yep. And then we had a little fun. Make sure you have a little concluding statement here, right? Thus, ergo, so, because I said so. Probably not that one, but in conclusion, henceforth, triangle dog, congruent to triangle cat. So we come up with one of these like rigid motion proofs. Make sure we have this wording in there so you get full credit. All right, there it is, rigid motions. All good, rigid motions. Next up, next topic, I graph a figure on a graph for you and I ask for its area. Okay, area on a graph. This one here, we're going to do number 6 together. 7 you can do on your own, so please don't get ahead or try to do it while I'm doing 6. This is a rhombus. Okay, hey, you guys got a lot of things you got to remember coming in here in 2 weeks. Maybe area of a rhombus isn't one of them. Maybe area of a rectangle isn't one of them. Doesn't matter. Doesn't matter. When it's on a graph, I prefer you to do it one way and one way only. What do I want to draw around this bad boy? To find its area. Box. Okay. I'm not going to use area of a rhombus formula. Maybe I forgot it. Fine. Still not an excuse. I can draw a box around this figure where each vertex is touching the box. And then find the area of the box. Length times width. Everybody can count. You don't need distance formula. Just count it. What is this? 6 by 8, I think. Yep. So this is 6 times 8. Don't get all happy here. They want you to fall in that trap. Hey, circle me, choice 4. That's just the area of the box, not the rhombus. Now you have 4 triangles surrounding the rhombus that you're going to find the area of and subtract it from the box. And remember, the area of the triangle you're going to use is 1/2 base times height. I believe that's on the formula sheet too, if you forget. And make sure you do base and height as the 2 legs, because they're all right triangles. So go ahead. I'll leave you guys to that. Should be getting 24. Okay, 24. The area of the 4 triangles adds up to 24. 48 minus 24 gives you 24 for the rhombus. Any questions there? I'll give you time to do number 7 in a couple minutes here. Any questions finding the area? I want you to box it in. All right, don't try using the formula if you think you know what the formula is. All right, I don't think it'll be pretty. Just box the darn thing in and make your life easy. All right, I'm going on. Last topic, and this will probably be the last topic that's on the quiz Thursday, Hills and SAS. You will see a Hills and SAS problem without a doubt. So down below, you got plenty of white space before the assignments listed at the bottom of your page. I just want to take a couple notes here. Number 1, how do I know this is a Hills-SAS problem? Either A, the diagram, or B, the wording of the problem. Hills and SAS will always be used in a right triangle. In a right triangle only. With, watch what I'm about to draw in. You tell me what I'm drawing in. I'm going to start from that vertex and draw this to the hypotenuse. I just drew an altitude in. So, altitude drawn to the hypotenuse. That's the wording I'm looking for. Altitude drawn to the hypotenuse. All right, let's label each of the pieces here that come up in Hills and SAS. First, I just said this was an altitude drawn to the hypotenuse. So if you're going to use hypotenuse in Hills, that's what you're going to use right there, that length. The other two sides of a right triangle are called your, bless you, legs. So they remain legs. All right, that's the L. We just said this was an altitude, right? If you want to put that, that's fine. That's an altitude. And then there's two more parts I need to label. Both are called the same thing, and that are the pieces on the hypotenuse, and those are called segments. If you want reviewing that. Okay, those are called segments. And there are all the pieces there. If you decide, here you go, if you decide to use hills, ready, H for hypotenuse, right? L and L. Same legs or two different ones? Do you remember that? Same legs or two different ones? Same, yes, same legs. They're called the means. They're always the same. Same legs. And real quick, this is a big one of it here. Which segment do you pick? Because it can't be any one you want. Stellan?
The one next to the leg you're using.
Yep. Leg adjacent next to, leg next to, leg being used. Segment. Here we go. Try that again. Segment next to leg being used. And before we hop into the problems, what if it's a SAS problem I need? What do you know about the segments? Same or different? Different, yep. And I'm not, the altitudes, there's only one, so they have to be the same, but different segments. All right, so there's a recap of Hills at SAS. We spent 2 days on that, but I just went over it in 5 minutes. I want to do both the problems with you, though, 8 and 9, before I let you loose. See the wording? This is the wording I was just referring to. Altitude drawn to the hypotenuse. Discussion's over. This is Hills SAS. Or you can see it on the diagram, too. Your call. I got a right triangle with an altitude to the hypotenuse, Hills and SAS. There's two other pieces we need to label, though. Length of DL is 4 times the length of BD. Label those, please, with something, and I'll ask you what you labeled it with. DL, 4 times the length of BD. Tell me what you're labeling and putting on there, Bailey?
DL is 4x.
Great. Yep.
BD is x.
Perfect. All right, good start. Now we got to decide. We know it's a Hills SAS because either A, the diagram looks like it, or B, I see draw to the hypotenuse. Now it's a matter of which one do I use. Bailey just labeled the segments. 6 is the altitude. I think we can put that all together here. Which two do I need? Which one out of the two do I need there? Jared, which one are you going to use? Me too. All right, fill it in now before we solve it. I need your help filling it in here. Cormac, fill it in. S.
X.
Altitude.
6.
Altitude.
6.
Segment.
4x.
All right, here we go, kids. Now it's your algebra ability. All right, we cross multiply. Oh boy, algebra 2 coming up in a couple months, believe it or not. 4x times x. Good, 4x squared equals 36. I know many of you become square root happy when you see the squared, but not until the x is by itself. Remember that. Don't get square root happy until the x is by itself. So yes, I need to divide both sides by 4. I get x squared equal to 9. So I get x equal to 3. Don't become happy yet. Make sure you solve what's being asked for. I'm going to find the length of BD. All right, BD I called x. I'm done. This problem could have easily said find DL. Find DL, and you'd have to multiply that by 4. All right, go to the last one here we're going to do together, and then you're on your own. Altitude FH to the hypotenuse. Look at that. Altitude to the hypotenuse. Got some lengths here, right? FH is 9. EF is 15. What's EG? Whew. What's going to be EG up there? Oh, well, we'll take a look here. Let's see. EG is the hypotenuse. 15 is a leg, and then I throw an altitude in there. Well, I'm solving for H, right? Hypotenuse. So this has got something that has to involve hills. So we start setting up hills. Hypotenuse. Leg, which needs to be the same leg. And then all of a sudden, right, I don't know what to put because I should be putting the segment next to 15, which is EH, but that's blank. Oh, it won't be blank in a minute. Look at that diagram. Can we find EH so I can finish this hills? I feel like we use it every unit, don't we? What can I use here to find EH? Don't overthink it. You got a right triangle there, right, Lauren? What can I use? You got it. So I can use Pythagorean theorem there. 9 squared. Make sure B squared, and 15 is your hypotenuse, C. Yeah, they're all right triangles, remember. So probably may not be as easy as just using Hills and Sass, and we're done. A little two-stepper here. Everyone getting 12 out? Leg equals 12. And then cross multiply. And we should end up with 18.75, I believe. Okay, 18.75. There are three problems that we did not do, numbers 1, 3, and 7. That's on you guys right now. So go through those. Here are the answers to those 3. And then you know where to go from here. Go to the end of day 5. Look at those Regents questions I'm suggesting.